Hello guys, today we are learning trigonometry basics. First off, we start with the most basic thing, which is the Pythagoras theorem. We all know that the Pythagoras theorem is a squared plus b squared equals c squared. So first of all, we know that a squared plus b squared equals c squared. But it also is the same as square root of a squared plus b squared equals c. But what if we have c and are missing, for example, a? So if we want to get a, we can do the square root of c squared minus b squared equals a. That's how we get it. Now let's go to the more advanced stuff. So we have sine that is equal to the opposite side over the hypotenuse, which is this side. Or in other words, the biggest side, and the opposite side is always the side that's opposite for the angle. So for our example, we would assume that we are using this angle over here. Then we have cosine, which is adjacent this side over the hypotenuse, which is this side. And then lastly we have tan, which is equal to opposite over adjacent. Okay, now we'll go to even something more advanced. So if we can see sine, we are using this side. We know that the other angle is complementary because this is a right triangle. So in this case, you see, the side which is adjacent to this side is the opposite of this side. So in other words, sine is equal cosine the other angle, because this is opposite to this and this is adjacent, and they are both over the hypotenuse. Next we have something a bit more advanced, is cosec and sec and cotan. Cosec is equal to 1 over sine, or equal to the hypotenuse over the opposite side. Same here, equals 1 over cosine equals hypotenuse over adjacent, and same here, equals 1 over tan is equal to adjacent over hypotenuse, opposite. Also, if you can see, they are multiplicative inverse of each other, so sine times cosec is equal to 1 cosine times sec is equal to 1, and tan times cotan is also equal to 1. You guys understand? Okay, let's go to the next thing. The asterisk rule, ASTC. So this rule is used to determine what is positive in which quadrant. This is the first quadrant, then we get the second quadrant, third and fourth. In the first quadrant, all are positive, so that means sine is positive, cosine is positive, and also tan is positive in the first quadrant. But then you go to the second quadrant, only sine is positive here. And then you go down to the third quadrant, you have only tan, and then in the fourth quadrant you only have cosine. That's the reason for ASTC. So we use this to determine what is positive in what quadrant, because look, here you have 30, but you then, when you put it in sine, it's also if this angle is 30, it would be half, right? Okay, but if you go here, it would also be half, but when you go down here, it will be negative half. That's why we use the asterisk rule to determine in which quadrant is the angle. Now, for the people who want to know how the asterisk rule works, you'll see that the opposite side to the angle, so the opposite side is parallel to the y-axis, and we know from before that sine is the opposite over hypotenuse, and the hypotenuse is positive. So, and in the first quadrant the y-axis is also positive, that's why it's positive here, and also here because it's on the above side. So sine is positive when it's up, but when you go down it's negative. Same with the cosine, because it's the adjacent side, it's positive in the first quadrant and in the fourth quadrant, so on the right side. And on the left side, x becomes negative, so that's why it's negative in both the second and the third quadrant. Because look, sine in other words is equal y, sine is equal to y over hypotenuse, and cosine is equal to x over the hypotenuse. So from before, you know what I already explained, this parallel to this, y over hypotenuse, that's why sine is positive here, and cosine is positive here, and then cosine is negative here, and sine is negative here and here. Then we get tan. Tan is equal to opposite over adjacent, which is equal to y over x. So we know that when we have a negative over here, say negative a over negative b, that is equal to just ab over b, because the negative cancels each other out. That's why tan is negative when both the x and y are negative. That's the reason why it's positive here and positive here. So when one of the both coordinates is negative, tan is negative. But when both is negative or both positive, is tan positive. And also, this is not only sine here is positive, it's sine and its opposite. So sine and cosec, tan and cotan, cosine and sec, and here is just opposite. So that's for today, our first video. I will be making a second video over trigonometry, going a bit more deep into it. And I'm also open to recommendations, and I post other videos about other topics. I don't only do math videos. So see you next time, guys. Bye.